Find the basic initial feasible solution to the following transportation problem using the Vogel's approximation method. Let's say there is a company in the US which has 3 factories, F1, F2 and F3. And these factories have a supply capacity of 7, 9 and 18 units per day. Now these factories have to transport the material that they produce to 4 warehouses, W1, W2, W3 and W4. And each of the warehouses have a demand which is 5, 8, 7 and 14 respectively. Now each of the factories can ship the material to any of the warehouses. So there is no constraint around shipping the material from any factory to any of the warehouses. And the cost of shipping 1 unit from each of the factories to each of the warehouses has been given to us, which is shown in the black color here. So for example, from F1 to W1, the cost of shipping is $19 per unit. For shipping material from F1 to W2, the cost of shipping 1 unit is $30 per unit, and so on. Now we have to find out the least cost route for shipping the material from these factories to the warehouses such that the supply and demand constraints are being met. So let's say that this is a company which is in the business of producing packaged fruits and vegetables. So it receives the raw material, that is fruits and vegetables, from countries in South America and then cuts it, processes it and packages them and then transport them to these warehouses across the country. For ease of receiving the material, the company has located its factories around the border. So let's say this is F1 and F2 is here. And F3 is here. And there are 4 warehouses which are located around the whole company, because this company distributes the processed fruits and vegetables around the whole country. So let's say warehouse number 1 is here. Warehouse number 2 is here. Warehouse number 3 is here. And warehouse number 4 is around here. Now warehouse number 1 has a demand of 5 units per day. So the demand is 5 units per day. Warehouse number 2 has a demand of 8 units per day. So demand is 8 units per day. Warehouse number 3 has a demand of 7 units per day. So demand is 7 units per day. And warehouse number 4 has a demand of 14 units per day. So demand is 14 units per day. Now factory number 1 has a supply capacity of 7 units per day. So supply is 7 units per day. Factory number 2 has a supply capacity of 9 units per day. So supply is 9 units per day. And factory number 3 has a supply capacity of 18 units per day. So supply is 18 units per day. Now the question is that there is a certain demand for each of the warehouses and there is a certain supply capacity for each of the factories. So how should we transport the material so that all the demand is met and at the same time the supply constraints are not violated and the cost is the minimum. So each of the factories can ship the material to each of the warehouses, and the unit cost of shipping the material from each of the factories to each of the warehouses has been given to us. So factory F1 can transport the material to W1, W2, W3 and W4. So F1 to W1, the unit cost is $19 per unit. From F1 to W2, the unit cost is $30 per unit. From F1 to W3, the unit cost is $50 per unit. From F1 to W4, the unit cost is $10 per unit. Similarly for F2, from F2 to W1, the unit cost is $70 per unit. From F2 to W2, the unit cost is $30 per unit. From F2 to W3, the cost is $40 per unit. And from F2 to W4, the unit cost is $60 per unit. Similarly for F3, F3 to W1 is $40 per unit. F3 to W2 is $8 per unit. F3 to W3 is $70 per unit, and F3 to W4 is $20 per unit. So with this data provided to us, let's use the Vogel's approximation method to find out the basic initial feasible solution. Now again, this is not the optimal solution, but the basic initial feasible solution using the Vogel's approximation method. So this is the transportation table that has been given to us in this example. In blue is the factories and their supply capacity. In red is the warehouses and their demand. And in black, we have the unit cost of shipping material from a factory to a warehouse. So the first step in solving a transportation problem is formulation of the transportation table. So formulation of transportation table. Now we have already been given the transportation table. However, in this transportation table, we need to check if the total supply and demand are equal. If they are equal, then the problem is said to be balanced. However, if they are not, then a dummy origin or destination is added to balance the supply and demand. So in our case, let's first add the total supply. So 18 plus 9 is 27, 27 plus 7 is 34, 14 plus 7 is 21, 21 plus 8 is 29, 29 plus 5 is 34. So both supply and demand is equal to 34. So in our case, the transportation table is balanced. So now we can proceed to step number 2, which is to establish the basic initial feasible solution, and in our case we are using the Vogel's approximation method. So the Vogel's approximation method makes allocations first to the cell with the highest opportunity cost or penalty cost. Now the penalty cost is determined by finding out the difference between the two lowest costs for each row and column. Because if we don't allocate as many units as possible now to the cell with the lowest cost in that row or column, we may have to allocate units later on to the cell with the next largest cost for that row or column. So the first step in establishing the basic initial feasible solution is to calculate the difference between the two minimum elements for each row and each column. So let's first go row wise. So the lowest cost for F1 is 10 and the second lowest is 19. So 19 minus 10 is 9. So this is the opportunity cost for first row. For the second row, the lowest is 30 and the second lowest is 40. So 40 minus 30 is 10. For the third row, lowest is 8 and the next lowest is 20. So 20 minus 8, 12. Now let's take the columns. So the first column, the lowest is 19 and the next lowest is 40. So 40 minus 19 is 21. In case of second column, lowest is 8 and the next lowest is 30. So 30 minus 8 is 22. In case of the third column, lowest is 40 and the next lowest is 50. So 50 minus 40 is 10. In case of the fourth column, the lowest is 10 and the next lowest is 20. So 20 minus 10 is 10. Now after finding the opportunity cost or the penalty cost, the next step is to select the row or column with the largest difference. So in our case, the largest difference is 22. So we select the column W2 first. The next step, which is step 3, is to allocate maximum number of units to the square with the minimum cost in the selected row or column. So the square with the minimum cost is this F3W2. So let's now evaluate the supply and demand position for F3W2. Now F3 has a supply capacity of 18 units per day, while W2 has a demand of 8 units per day. So even though F3 can supply 18, demand is only for 8. So let's allocate 8 units here so that the entire demand for W2 is satisfied. So with this allocation, now the demand at W2 becomes 0, while the supply at F3 becomes 10, that is 18 minus 8. Now after the allocation, the next step is to cross out the row or column completed by the assignment. So here in case of F3, there is still some supply capacity available to allocate to other warehouses. However, the entire demand for W2 has been met. So we don't need any other factory to allocate anything or ship anything to W2. So let's cross off these two boxes here. which is F1 W2 and F2 W2. Now again, let's determine the opportunity cost for the remaining row and columns. And in this case, we'll now ignore the ones which are either allocated or have a cross mark. So for the first row, the lowest is 10 and the next lowest is 19. So the difference is 9. For the second row, lowest is now 40 and the next lowest is 60. So the difference is 20. For the third row, the lowest is 20 and the next lowest is 40. So the difference is 20. In case of columns, for the first column, the lowest is 19 and the next lowest is 40. So the difference is again 21. For W2, we have already completed the allocation, so we'll ignore this. For W3, the lowest is 40 and the next lowest is 50. So the difference is 10. And for W4, the lowest is 10 and the next lowest is 20. So the difference is 10. Now let's evaluate the row or column which has the highest opportunity cost, and that turns out to be W1 with an opportunity cost of 21. So let's allocate the maximum that can be allocated to the cell in this column with the lowest cost. So that cell is F1W1. Now let's evaluate the supply and demand condition here. F1 can supply 7 units, however W1 has a demand of 5 units only. So let's allocate 5 units here. Now with this allocation, the entire demand for W1 has been met, so this becomes 0, while the supply available becomes 7 minus 5, which is 2. Now since the demand for W1 has been completely met, so there is no need for any other factory to ship material to W1. So let's cross off the remaining boxes, indicating that they don't need to be allocated. So now for the remaining rows and columns, let's again find out the opportunity cost. So for the first row, the lowest is now 10 and the next lowest is 50. So the opportunity cost is 50 minus 10, which is 40. In case of the second row, the lowest is now 40 and the next lowest is 60. So the difference is 60 minus 40, which is 20. In case of the third row, the lowest is now 20 and the next lowest is 70. So the difference is 70 minus 20, which is 50. Now in case of the columns, we can ignore W1 and W2 because those are completely allocated. In case of W3, the lowest is 40 and the next lowest is 50, so the difference is 10. In case of W4, the lowest is 10 and the next lowest is 20, so the difference is 10 again. So now let's evaluate which row or column has the highest opportunity cost. So F3 has the highest opportunity cost, which is 50. So let's try to allocate the maximum number of units to the cell in this row which has the lowest cost. So that cell is F3W4. So now let's evaluate the supply and demand condition for this cell. So F3 has a supply capacity of 10 units while W4 has a demand of 14 units. So since we can only supply 10 units from F3 to W4, let's allocate 10 units here. Now with this allocation, the demand is 14 minus 10, which is 4, while the supply capacity remaining is now 0. So now since F3 has exhausted its supply capacity, let's cross off the remaining boxes for F3, indicating that F3 is now no longer available for allocation. Now let's again find out the opportunity cost for the remaining rows and columns. So for F1, the opportunity cost is 50 minus 10, which is 40. For F2, it is 60 minus 40, which is 20. We can ignore F3 because it has been completely allocated. Again, for columns, we can ignore W1, W2. In case of W3, it is 50 minus 40, which is 10. In case of W4, it is 60 minus 10, which is 50. So let's find out which row or column has the highest opportunity cost. So it appears that W4 has the highest opportunity cost of 50. So let's now allocate the maximum number of units to the cell which has the lowest cost for this column. Now that cell is F1W4. So now let's evaluate the supply and demand condition for F1W4. So the supply capacity available at F1 is 2 units, while the demand at W4 is 4 units. So we can allocate 2 units here. Now with this allocation, the demand remaining at W4 is 2 units, while the supply remaining at F1 is 0 units. So now since F1 has completely exhausted its supply capacity, F1 is no longer available to supply to any other warehouses. So let's cross off this box F1W3, indicating that it is no longer available for allocation. So now we only have one row remaining which has unallocated cells, which is F2W3 and F2W4. So now let's again evaluate the opportunity cost for the remaining rows and columns. So F1 can be ignored. For F2, the lowest is 40 and the next lowest is 60. So the opportunity cost is 20. For F3, you can ignore because everything is already allocated. Again, for W1, we can ignore because it has been completely allocated. W2 can be ignored. For W3, the lowest is 40, but there is no next lowest, so we can ignore this also. And again, the same thing for W4, the lowest is 60, but then there is no second lowest, so we can ignore this one as well. So now the highest opportunity cost is for F2. So let's allocate the maximum units to the cell which has the lowest cost for F2, and that cell is F2W3. Now let's evaluate the supply and demand condition for F2W3. So F2 has a supply capacity of 9 units, while W3 has a demand of 7 units. So let's allocate 7 units here. Now with this allocation, the demand at W3 is 0, and the remaining supply capacity at F2 is 9 minus 7, which is 2 units. So now we have only one square which is remaining, which is F2W4, which has not been allocated. So let's evaluate the supply and demand condition for F2W4. F2 has a supply capacity of 2 units, while W4 has a demand of 2 units. So let's evaluate the supply and demand condition for F2W4. F2 has a supply capacity of 2 units, while W4 has a demand of 2 units. So we can allocate 2 units to this cell. And with that allocation, the remaining demand at W4 is 0, while the supply capacity remaining at F2 is also 0. So with this allocation, we have completed our entire allocations, and all the supply and demand has been allocated. So this is our basic feasible solution, where factory 1 will be shipping 5 units to warehouse 1, and factory 1 will be shipping 2 units to warehouse number 4. Factory number 2 will be shipping 7 units to warehouse number 3 and 2 units to warehouse number 4. Factory 3 will be shipping 8 units to warehouse number 2 and 10 units to warehouse number 4. So let's now find out the total cost of transportation that we have achieved using the Vogel's approximation method. So first the shipment from and to. Next is units shipped. Next is transportation cost per unit, and then the total cost. So the first allocation is F1W1. So the shipment is from F1 to W1. The number of units shipped is 5, and the cost per unit is $19. So the total cost is 19 multiplied by 5, which is 95. Now all this is in dollars. Now the next shipment is from F1 to W4. So F1 to W4. The number of units shipped is 2, and the cost per unit is $10. So the total cost is 10 multiplied by 2, which is $20. The next shipment is from F2 to W3. The number of units shipped is 7, and the cost per unit is 40. So the total cost is 7 multiplied by 40. So 7 fours are 28, 2, 8, and then 0. The next shipment is from F2 to W4. So F2 to W4. The number of units shipped is 2, and the cost per unit is 60. So the total cost is 60 multiplied by 2, which is $120. The next shipment is from F3 to W2 for 8 units at a unit cost of $8, and the total cost is $64. And the last shipment is from F3 to W4. So F3 to W4, our number of units shipped is 10, and cost per unit is 20, and the total cost is $200. So the total is 5 plus 4 is 9, 9 plus 2 is 11, plus 8 is 19, plus 2 is 21, plus 6 is 27, 7 and 2 carry over. So 2 plus 2 4, plus 1 5, 6 and 7. So $779 is the total cost. So this is the total cost.